Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to take a quick look yet again at the moon and talk a little bit more about the Artemis II mission to the moon, the first crewed mission to the moon in decades. To take a look at the moon, we're going to have to wait for it to come up. Of course, we had our full moon on the 1st of April, so it's going to take a little bit longer for the moon to come up now that we're through to the, through to the 8th of April. Of course, the Artemis mission must be near the moon, and for us here in Ireland, the moon isn't going to come up until, well, it'll come up pretty close to 5 o'clock. We're here at just 5:30 on the 8th of April. That's when the moon is going to be up and visible for us. We can see that it's not quite at last quarter. Last quarter is the half moon that we get after the full moon. We can see that it's not quite there yet. We need to go a little bit further to get to half, and of course by around the 10th or the 11th the Artemis II mission will be back. It will be back home. It will be back here on Earth, if everything goes according to plan at least. So this is when we're next going to see the moon from here in Ireland, and currently at the time of recording, the Artemis mission has just gone behind the moon. So by this time, by the time we're through to about 5:30, I would expect the Artemis craft to have come out from behind the moon. The far side of the moon is often called the dark side of the moon, and we're going to go quickly to the sun in order to take a look at the moon. We call it the dark side, but the far side of the moon and the near side of the moon both receive just as much sunlight. If we simplify things and say that the moon takes a month to go around the Earth, then 2 weeks of that time the moon is in darkness, and 2 weeks of that time the moon is in the light. Now, of course, the sun is a big place, so we may need to get rid of the ground to actually see the moon and the Earth. Well, there we go. There's the Earth, and the moon can't be far away. The moon and the Earth are far too close together to appear particularly distant from the sun. So here we are looking at the moon, and we are still looking at the 8th. We are now looking at 4:30 in the morning because we're no longer paying attention to summertime, which adds an hour to the time that we use here in Ireland. Here we go. We're seeing a little bit of what we would call the dark side of the moon and a little bit of what we would call the light side of the moon, simply because the moon isn't completely new from the sun. If the moon was completely new from the sun, then we would only be seeing the dark side of the moon. And here we are, I believe. Yep. After moving forward, a little bit of a twist there, the dark side and the light side of the moon. So this is the dark side of the moon. I think more like this, because we have these two very small mare here, and we have some mare, or at least darker regions that are associated with craters, but the vast majority of the dark side of the moon is incredibly pale. It doesn't have those big seas or mare that we see on the light side of the moon. So turning it around, here's the light side of the moon, covered in these dark seas and plains with only a smaller region that's completely white. So the dark side of the moon is brighter. It at least reflects a little bit more light. It looks brighter. The dark side of the moon looks brighter to the eye, and it will to those very few astronauts who've gotten to go and see it. Of course, it is only a small number of astronauts who have gone around the far side of the moon. And when a spacecraft is in that position, there is a comms blackout or communication blackout. The dark side of the moon is dark in terms of our knowledge. We don't know as much about it, and it causes a comms blackout. It blocks your view of the Earth. If you are a spacecraft orbiting the moon and you're on the far side of it, you can't talk to the Earth. And that is what happened with the Artemis II mission just a couple of hours ago, as of the time of posting. Quite a while ago, quite a good few hours ago, compared to 4 o'clock, 4:30 in the morning here. We're going to return to the Earth, and we're going to see if we can see where the Artemis probe is, or where it would be, where it should be at this time. So we're back to 5:30, that is correct. And we're very much taking a close look at the moon, as we were, of course. So at this time, 4:30 really, according to UTC. NASA knows, and various people know, where the Artemis spacecraft is. Unfortunately, spacecraft are not something that Stellarium is usually aware of. There are some extra things coming up here because Stellarium did have an update, but the Artemis mission, the Orion capsule, isn't there. We have loads of things to do with Orion, but none of them are the Orion capsule, which is the spacecraft carrying the astronauts on this Artemis II mission. Artemis is really the name of the mission, and Orion is the name of the capsule. Luckily, even though Stellarium doesn't know, people do know. It is tracked. We do know where the Artemis II mission is, and you can find out for yourself where it is in the sky. So this is the Jet Propulsion Laboratories Horizons System. If you go to the JPL website, it's under the Horizon System. It's the app. This is a system that allows you to figure out where something is going to be in the sky, and it does track various spacecraft. So we can look up the Artemis II, 2 in Roman numerals, of course, that's the spacecraft. The default observer location assumes the center of the Earth, which is, for mathematical reasons, for calculating various orbits, it's a good default location to go with, but you can put in your own location. You can add in where you are on Earth, let's say 8 degrees west and 52 degrees north, near Cork City. The full range, the full sort of grid of lat longitude does encompass a reasonably large space, but Cork would be included in this. The exact coordinate might be a little bit off. The Orion capsule, the Artemis space mission, is only tracked for certain times, so we need to make sure that the start time and the stop time line up with the minimum and maximum. They're a little over precise to me. I don't need to know within millisecond accuracy where everything is, so we're going to change these. We're going to simplify them just a little bit, just to make things easier for our increments, because this mission, this whole mission, is occurring over the course of only a few days, only 10 days. So if we calculate where it is in the sky once a day, we'll get some very spread out positions. This will make sure that we get exactly the range in which we want to see. And there's a lot of these things that we don't need. How bright things are going to be, where the sun is. A lot of this kind of information would be more to do with if you were looking for an asteroid or a comet. Really all we need is the astrometric RA and deck. The apparent RA and deck are corrected for the atmosphere, because the atmosphere will bend things. So when things are lower in the atmosphere, they will apparently get, it's just like the sunrise occurring a little bit before it technically does because of the light being bent. All of that will generate a big list for us. There's loads of details, loads of hints on how to read the list, but this is really what we're looking for. It gives you the time and the RA and the deck. Of course, this is almost the entire length of the mission, so we need to go to the time and the date that we're looking at. I went with the whole span of the mission just to show that you can get this information, and we're really looking at 4:30 UTC. This is the coordinate that we need. So I'll see if I can copy and paste them. There's a good chance I'll have to write them in manually, but we'll give copy and paste a shot. This is the position search window. So we're looking for a specific position rather than a specific object or a known thing. We know what we're looking for. We're looking for the Artemis II mission, the Orion capsule. Stellarium doesn't need to know that. Stellarium only needs to know where we're looking, and hopefully that will do it. Perfect. It was only a subtle movement, but that moved just a little bit away from the moon. We can now put a little marker there. This is marker 3 because I had a little bit of practice before I started recording. That is the location. I'm a little bit off. We'll zoom in, we'll try and be a little bit more precise. And we need to pause time, otherwise things will drift away from us. We want to be looking at exactly 5:30, so we're also a little bit at the wrong time here. Let's come back just a little bit, because this does depend. It is very sensitive to the time of your observation as well as the location of your observation. So even here, we're going to be almost a minute off, but this should be just about the location of the Artemis II mission from the Earth at this time when it first becomes visible to us. And you can do this for anywhere. These are just the coordinates for Cork City. You can shift these coordinates to be wherever you are. And you'll see, as well as the time, so we have our date and our time over on the left-hand column, and over on the right-hand column, so we've got RA and then DEC. In between, we've got whether or not the moon is up and whether or not we're in astronomical, nautical, or civil twilight. So these are to do with the moon rising, the moon being up, the moon setting. This is a little bit of extra information to help make sure that you're, looking at the right time. And of course, here we are, 4:30 UTC. It's showing that as the moon being up and astronomical twilight. And indeed, if we come back to here and we zoom back out, we can get rid of these now. We might notice that the sky isn't completely dark. There is a little bit of glow coming into the sky from the sun, and that's our astronomical twilight. So that's where the Artemis II mission is going to be when we next get a chance to see it from here in Ireland, but using the JPL Horizons System to get the Ephemeris. That's what these little details are called. This is called the Ephemeris, but it's only a little bit of the Ephemeris, only the RA and DEC. It'll tell you when you need to look in the sky. You just have to correct for UTC, you have to correct for your local time, whatever it may be. So I hope, even if you don't get to see the Orion capsule in space, you would need a pretty good telescope to see it. We now know where it's going to be, just starting its return mission to the Earth after coming back out from behind the moon. That's where it's going to be at this time when we next get to see it here in Ireland. I hope you get a chance to see it, or at least find out where it would be, no matter where you are. I hope that you enjoyed this video. If you did, please do like it. If you like this kind of content, then please subscribe to my YouTube channel. And if you'd like to read this information, you can do so on my website, queeveenscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.